Hello, students. Welcome to today's topic on dimensions and error analysis from SI units and measurements. Yeah. So, what is measurement basically? Let's start from the term measurement and why do we need it? So, as we all have considered in the last session that physics is describing the laws of nature. Now, there exist physical quantities which needs to be measured, which needs to be justified, basically. So when you need a justification tool and a universal justification tool to not only understand the dynamics of that particular physical quantity, but to also cause a relation, a relativity between two physical quantities of the same nature. Like if one quantity is measuring to you to be as 500 kg and one to be as 1000 kg, isn't there a difference? Yes. So to hold on to that difference, we need measurements and a universally appealing tool which will measure it universally same. Dimensions. All the physical quantities of interest can be derived from the base quantities of dimensions. When a quantity is expressed in terms of base quantities, it's written as a product of different parts of the base quantities. Okay. The exponent of that particular base quantity will enter into that expression, calling to be as the dimension of that particular quantity. This is the scientific definition of what a dimension actually means of a particular quantity. The exponent, the exponent of the base value, like if it is m2 L0 t minus 1. So this 2, 0 and minus 1, they are describing the dimension of a particular base quantity. To make it clearer, consider the physical quantity force. Yes, force is equal to mass times acceleration. Mass times acceleration. Now, what is acceleration? Meter per second square. It's measured in the distance traveled in second square. Means the rate of change of velocity. The rate of change of velocity is known as acceleration. So this acceleration, when I am calling for, is standing out to be LT minus 2 times m. So those are the dimensions of force. Force is m L T minus 2. Likewise, we will be deducing all the relevant, all the important physical quantities and the dimensional formula of them in my upcoming sessions. Just likewise, ml to t minus 2 is the dimension of energy. Now let us see the dimension of certain constant like a solar constant, where from the name you cannot deduce anything. The solar constant is an intensity framework. So it's energy upon area times time. So for energy, as I have told, it is coming from the dimensional formula ml2 t minus 2, which also will be dealt in my upcoming sessions. Upon area is L square times T. And when we are doing that grade 10 mathematics, we are getting mt minus 3. How? Because m standing as m, t minus 2, t1 from the denominator coming upside, minus 3, L square getting a substantial cancellation, and we are getting the dimensional formula of solar constant to be mt minus 3. Yeah. Likewise, we should also know that area, we are always deducing the area of any x faculty to be in unit square. Whatsoever be the unit, it will be square of it. That's how we are considering area. And then for volume, it's cubic unit. Yes. The second subtopic of the particular. Okay, before that, let's consider certain base quantities which you all should know. And you need to cram it. No two ways. But yeah, MLT, as we all know, they are mass, length, and time respectively. The name of the unit will be M standing for kg kilogram, L will be meter, and time will be second. Electric current will be ampere. Thermodynamic temperature will be Kelvin. amount of substance standing out to be in mole, luminous intensity to be in candela. Candela, unit which you should remember, but we should not need to learn. Like it's not learn in the sense of not cramming it to deduce other quantities. Like mass will be coming into more application than candela. Next, what do you mean by error? See, to be very simplifying, I would say that when the real value is not meeting up to the measured value of any x physical quantity, you can call it to be the error. Now, error are of two types. They are of two categories. One will be the device error, which you can call under the category of the directional error. Every device holds directional error. I must tell you that. That is also known as the zero error. It is a personal error. Why personal error? Because it's the error while making a measurement. It is the error which we will make. We will make and we will be making it in case of every graduated measurement, like measuring device, like scale, like test tubes. Everything holds a certain grade of personal error, directional error, device error, all meaning out to be the same. On the contrary, or on the other end of the spectrum, we have non-directional errors, which are environmental errors. Environmental errors can also be considered as to be random into division. Like when you are calling for the fermentation of a baking soda or fermentation of a bread, it will vary climate wise. If you are calling the fermentation of and the bubbling out of CO2 within 4 hours in summer season, you may witness it in 6 to 8 hours in winter season. So have we changed the process of fermentation? No. What has changed? Environmental error has changed. It has been introduced because you will find lesser humid content of in the atmosphere when we are considering the winter seasons. So that's a non-directional error. It's very random and it cannot be controlled also. Yeah. Least count error. Least count error can be of smallest measurement a device which can make. It is the smallest measurement, and it's also called the LC error. Meter scale. Of meter scale, it is 1 millimeter. Of vernier calipers, it stands out to be 0.1 millimeter. Of screw gauge, it stands out to be 0.01 millimeter. Yeah. Percent error. These are certain relevant formula which you must know when we are solving the error analysis questions, because these are all the formula which will be coming into play. Relative error times 100, which is a delta E upon A real times 100, where delta A is the real measured value and is also known to be as the absolute error. Now let's consider a question in which a meter scale is giving us measurements in which the real length is standing out to be 20 centimeter. We need to calculate the absolute error in this case where the measured value is coming out to be 16 centimeter. Relative error and error percentage also needs to be calculated. What will be the thing? How will we casting calculations? Absolute error is 4 centimeter, 20 minus 16. Relative error is delta L upon L real. Stands out to be 4 by 20, which is 1 by 5. And percent error, just giving it a multiplication of 100 will be posing you the error percentage. So likewise, we will be dealing more with the numericals, less with the concepts in error analysis, screw gauge, vernier calipers, the graduations, the least count error, all coming into play in the upcoming sessions. I hope you all understood the topic much well. Keep practicing, students, and I'll see you next time. If you have any doubts or any queries, please contact my Urban Pro profile. Thank you so much.